Good morning, students. In this video, we will discuss on one of the important error detection technique, that is cyclic redundancy check. Okay. So cyclic redundancy check, we have n number of versions like a CRC3, CRC4, CRC16, CRC32. So we have n number of CRC version techniques. So uh, the more information about these various techniques, I have made a video, and it is the link has been available in the description box once you watch that. So based upon the type of CRC we are using, so if we are using CRC3, then the polynomial, we call it as standard polynomials, that is one of the components we are using in CRC that helps in generating the code word, which is responsible for even identifying the errors, means detection of errors. So that component, what we call it as a generated polynomial, or we can call it as a divisor, is mainly depends upon the type of CRC that we are using. If you are using CRC3, the polynomial is x cube plus x plus 1, that is 1011. And if you are using CRC12, it is something different. If you are using CRC16 or CRC32, it will vary. So that's what I recommend you. First you watch that video where you will come to know the various types of CRC versions, as well as what type of polynomials that we are using. Okay. So however, in this video I am using CRC3 concept. When I say CRC3, its standard polynomial will be x cube plus x plus 1. Or if you convert that into binary, it is 1011. So when I say CRC3, you can see this is what the table where it is showing the data word and the code word. So this code word we need to generate. That will help in transmitting the data from source to destination. So this is the data word. This may be of any number of bits. Here I have taken 4 bits. That's what the name, a CRC code with 4 bits. This is what 4 means, data word. And what is the code word? When I am using CRC3, you need to add additional 3 bits. We call it as redundancy bits that helpful in error detection. So why we are adding 3 bits? Because in CRC3 the standard polynomial is x cube plus x plus 1. The highest polynomial is the number of additional bits we need to add. So here it is 3, so 3 bits are added. Or if you convert that into binary, you will get 4 bits. So we can write n minus 1 bits. You need to add extra, that is 4 minus 1, 3. Any case is possible. Either you can check the highest polynomial, or you can see the number of bits minus 1 in the case of binary. So that is what the indication, how many extra bits we need to add. Okay. So when I add 3 bits, it becomes 7 bits totally. 4 bits of original data and remaining 3 bits of redundancy data. Okay. Total 7. That's what the name, CRC C of 7, 4. 4 bits of data word, 7 bits of code word. Okay. But here, as I told, no, the data word may be any number of bits. If it is 5 bits, then it becomes C7, 8, 5, because 3 extra bits we are adding. Like that, it will vary. So now, very important is how we need to generate this code word. Means how we got these 3 additional bits. These 4 bits are data word only, but what about these extra 3 bits? So that we need to know. That's what CRC will help in identifying or generating those 3 bits, appending to the data word, which forms the code word. That code word you are sending to the receiver, and you are checking at the receiver side whether the data received is correct or not, or any error has been introduced. So let's start. This is what the general model of CRC. So this is at sender side, and this is at receiver side. So at the sender side, the first step, as I told, we need to send the data. So this is what the data we are sending, which is of 4 bits. So here there are 4 bits of data word, A0, A1, A2, A3. So for example, I will take one of the scenario as example. I will take 1, 1, 1, 1. So this is my data word. So this is 1, 1, 1, 1. So A0, A1, A2, A3. So all these 4 bits are added to the generator, and here you can see this is what the data word, and we got additional 3 bits. So we need to calculate that. So in order to calculate that, so first the generator will take care of that. So generator, what it is doing, 3 bits, first it is appending 0. Okay, totally now the generator we are getting the input as 1 1 1 1 1 1 1 1 and then 3 zeros. Okay, then what we are doing, we are applying what is known as divisor to this. We are giving the input as the divisor. Okay, and this divisor is nothing but your standard polynomials. Here I told you these are the polynomial. This is the standard polynomial, that is 1011, and that is shared already between sender and receiver. So both the side the divisor is responsible to generate these bits. So this is nothing but 1011. Okay, so this divisor we are doing division with to the this data, that is 1 1 1 1 0 0 0. This is what your generator is having input. This I am taking it as a divisor now, 1011. So now you start doing the binary division using XOR operation. Then whatever the data you will get as the remainder, that you need to append it to these 3 zeros. Then you will get what is known as code word. So that I will show in the next slide. And that code word you are sending to the receiver, all 7 bits. And this will again taken as the checker. Those 7 bits again we are doing the XOR operation with the same divisor 1011, and you will get 3 syndrome bits as the reminder. Okay, if all the bits are 0, then it is understood that there is no errors in the code word or the data that is received. So if all are 0, then what it will do, it will extract only the data word. This is what your data word. We are not bothered about these bits. So these 4 bits are taken and it is sent to the receiver application layer. If one of the bit in the syndrome bits is 1 other than 0, if it is having any other number, then it will just discard, indicating that there is some error. So this we will see how exactly it will calculate by taking one suitable example. Okay, also I understood this model. First it is taking the data word 4 bits, we are appending 3 extra bits, then it will calculate the code word. This is what the code word, it will calculate 111111, 7 bits. Then that is sent to the receiver. All bits are taken, all the code word is taken, again the checker will do the division. Then if all the bits are zeros in the syndrome, then the data is correct, so it will extract only the data and then it will send. If one of the bit is not 0, then it will think that there is some error and it will discard. So we will see one small example for this. Okay, for the data word 1001, means which one I am taking, this one, this one, a small scenario for the data 1001. What is telling, find the code word. Okay, what is the code word? 1001110, that we need to identify, means 100110, sorry, 1110. So this is what the code word, we need to find that code word, and this is what the polynomial. In the exam either they may give that polynomial or they may not give. It is standard. Okay, if they have not given, you need to assume as 1011. If they given, well and good. So check at the receiver side whether the code word received is correct or not. Okay, now we will see one example. So same thing I told now, this is what the data word 1001. Okay, what they have given, means here 11001. So I will just clear it, wait. Sorry, 1 second. One second. Okay, so what is that? 1001. So I will just write it here as 1001. Okay, and find the code word is asking. So how many zeros will append? 3 zeros. That is what? Now partial code word. This is 1001 and 3 zeros. That is 1001 000. That is what the partial code word we have taken here, 1001 000. So whole thing is goes to the generator, then he will take the help of divisor, that is what, 1011. Okay, so that I am dividing now, 1011. So what you should do, you just see the first character number, it is 1, so it goes 1 times, 1011 1 time, you will get 1011. So you do the XOR operation. If in XOR operation, please remember, if both bits are 1, that is 00 or 11, it is, the result is 0. If one of the bit is different, either it is 01 or 10, the result is 1. That is what XOR operation. So here you can see now 1 1 it is 0, 0 1 0, oh sorry 1, and 0 0 0. This you can cancel. Next I will borrow one more 0 here down. So now it is 0 1 0 0. So this is 0 is there. So 0 times 1 0 1 1, 0 times all zeros. So 0 0 is 0, 0 0 is 0, 1 0 is 1. But this you can cancel. And again I am borrowing one more 0. So now it is 1 times. Here it is 1. So 1 times. Nothing but 1011. 0 1 is 1, 0 1 is 1. This is 0 and this is again cancelled. And again last one more 0. We should do 3 iterations. Again 0 it comes. So it is now 0 is there here. So 0 times all zeros. Then 0 0 0 1 1. This you can cancel. So this is what 1 1 0 is the remainder. So the zeros which you assumed previously, now you should replace with those zeros. That is, now you should replace as 1 1 0. So this is what your code word now. So what is the total code word now? 1001. This is what your data word, and extra 3 bits. What is that? 110. This is what your code word. Now understood now. So this is what now, 1001, and also what are the extra bits? 110. 110. So if you want, you can check it. See here, 1001 110 is the code word. So in this way you are going to generate the code word, and this code word you are sending to the receiver. So either the same code word may receive, or one of the code word bit may change. So two scenarios we will see. First we will see that exact code word is received, there is no errors. 1001 110, everything is same, correctly it has received. So what the checker will do at the receiver side, it will take all the bits and it will again divide with the same divisor, that is 1011. So apply the same operation what I told. Sure, you will get all 3 bits at the remainder at 0 0 0. If you want, you can see here, they have done it here. See, I have taken the same data code word, there is no change. Divide with the same 1011, same process you apply, you will get all syndrome bits as 0. Okay, so I told now when all the syndrome bits are 0, then it is understood that that is correct. Then it will extract only the data word 1001, that is 1001, and it will send to the application layer telling that there is no error. In case if there is any change, here you can see one more scenario, 1000 means 4th bit is changed. Okay, I have changed it from 1 to 0. 110 is received at the receiver side. Okay, just an assumption. Here it is changed, this is changed to 0. Now if you again divide it with the same divisor, you will not get the remainder as 0. You will get as 0 1 1, something else. So I told now if all the 3 syndrome bits are 0, it is correct, like this. If one of the bit is something 1, it is wrong. When there is some changes in the code word. So it is understood that there is code word. Then what it will do? Immediately. Now what are the syndrome bits here? 0 1 1. So it is 0 1 1. So it will just logic decision will be, it will discard the code word, thinking that there is some error. So in this way, the CRC will help in generating the code word and then checking the code word whether it is received properly or not. Okay, hope so you enjoy. So same thing can be done in polynomials, which you will see in the upcoming videos. So same calculation can be done using polynomials. Till now what we did is binary. The same thing can also be done in the polynomials. Okay, hope so you enjoyed the video. So thanks for watching. Subscribe my YouTube channel for more videos. Bye.